Hello, in this video we will talk about encoding and decoding in Python. So when we use a character or text in Python, it usually stores in the Unicode character. So Unicode character over 100,000 characters for all the languages or the symbols in this world. So it is okay, it just work with Unicode, it's inside Python. But if you use outside data text, then take this text in the Python, for example, web page or other sources, then it will usually encode automatically this kind of data to bytes data. So it is called bytes data. So from character string to bytes, this process is called encoding. And if we transform bytes to the character string, this process called decoding. Because we work with Unicode character, we work with character Unicode string, then usually we will decode these bytes to string if we get outside data. So we have to know which kind of encoding this text has been encoded into bytes. Then we can use this same mechanism to decode these bytes to the character string that we can use later, right? So this is the idea for encoding and decoding. And then we say which kind of mechanism for encoding, and this is UTF-8. So although there are more than this encoding scheme in the computer science, but UTF-8 is the most widely used. And this is a dynamic encoding scheme. So from each Unicode character, it is encoded with 1 to 4 bytes. So this is called dynamic. So for the old ASCII character 128 in ASCII, then use only 1 byte. It's enough. But for the Latin character, use 2 bytes. And then for the next plain, rest of the basic multilingual character, use 3 bytes to store each one. And for Asian language, for example, use 4 bytes to store in the bytes data. So this is the UTF-8 encoding. Then we know this. If we know, or we say, we can say most probably it is UTF-8 encoding, then we can use same UTF-8 as the parameter in the decoding. So encoding and decoding must be matched, right? Must be the same. So if for example, this encoding use other coding process than UTF-8, then we have to use the same decoding in the parameter. So next we go to Python to take a look at concrete examples for encoding and decoding. So for example, we create character. And because this symbol backslash with U, which means it's a Unicode for the character, and with this number, this represents one particular character in the Unicode form. Then we show this character. It's a very strange character, right? There's a picture symbol. Then we can use the length function. It is only 1 because this is a string, 1 string. Then we use encode with UTF-8. So this character Unicode will be encoded as process from UTF-8. Then we can use this string dot encode UTF-8. Then we show the length of this object has 3. You can see this is 3 because there are 3 bytes. So we directly show this bytes data. So start with B, then in quotes is 3 bytes, 1, 2, 3. Because this belongs to, not belongs to Latin, not belongs to the ASCII character, so it is used with 3 bytes, and it is not an Asian character. And you can, of course, you can try other encoder, but maybe get some error. So for example, we try encode with ASCII to this character. So we see what happens. So you can see the error is because this cannot be encoded in the range of 128 according to ASCII encoding, right? Because ASCII only can accept 128 different characters. And if you want to encode and you want to ignore this error, you can set a second parameter, for example, ignore. Then the result is empty, and we can also use the replace as the parameter. So if Python cannot encode successfully, you will replace it with a question mark. And you can use this \replace if you want to bypass this error and encode as a type of Unicode. So now we come to the decoding, and we create a string first, cafe, CAF, and the last character is a special character for A. Then we show this string cafe, then type of this string is a string. So up to now, this place object is a string and stored in the Unicode, right? Unicode is just special because this fourth character is in very later plane in the Unicode. Then we can encode this string to the bytes using UTF-8 scheme. Then we show these bytes stored. Can see bytes CAF. Then the fourth, actually this string stored in 5 bytes. So the first 3 bytes is same as in the Unicode itself. And 4th and 5th bytes for this special character. Because this is actually is, you can find it in ASCII. So we know in ASCII, this 128, the most common character, is stored in as 1 byte, right? So this is same as you can see same as the Unicode. So now this bytes object has 5 bytes, and I can show the type of this object is bytes. So if you're not secure what kind of object, you can use type function to show it is string or the bytes. And if we want to decode back to the string, so we can use decode UTF-8 for these bytes. And the result is correct cafe. But if you try to other kinds of decoding, other kinds of encoding scheme in the decode function, so say we use ASCII int decode for this bytes object, so it is error because this ASCII only can accept 128 in the range for. But it's, of course, this is much higher than 128 for the last character. And if we use Latin-1 int decoding, so it is not correct, right? The fourth. And if we use Windows 1252 in this, also not correct. So it is very important that you have to know which kind of encoding you have did from text to the bytes. And then you can use the same encoding scheme in a function for the decoding back to the string. And if you do not know this, but usually we try UTF-8 in the decoding, right? And in the web page, if you get the data, normally it will use UTF-8 encoding scheme to the bytes. Thanks for watching.